This is my report about DC motors and DC generator. Electrical machines are important devices that convert electrical energy into mechanical energy and vice versa. Two common types of electrical machines are the DC motor and the DC generator. These machines are operated using direct current DC and are widely used in main applications such as industrial machines, electrical vehicle, fan, pumps, and power system. Although they have similar parts and in structure, their functions are opposite. A DC motor converts electrical energy into mechanical motion, which while a DC generator converts mechanical energy into electrical energy. Understanding how this machine work is important in learning electrical technology and power system. DC motor. A DC motor is a device that converts direct current electrical energy into mechanical energy. In simple terms, it changes electricity into motion. DC motors are commonly used in devices that require control, speed, and torque such as electric fan, conveyor belt, cranes, elevators, and electric vehicle. The work principle of the DC motor is based on electromagnetic system. When electric current flows through a conductor placed in magnetic field, a force and produce that causes movement. This principle is explained by Lorentz force. The magnetic field interacts with the current in the armature windings, producing torque that rotates the motor shaft. Main parts of a DC motor. 1. Stator. The stationary part of the motor that produces the magnetic field. 2. Rotor armature. The rotating part where electric current flows that mechanical motion is produced. 3. Commutator. A mechanical switch that changes the direction of current in the armature windings. 4. Brushes. Conductive materials that maintain electrical contact with the commutator. 5. Field windings. Coils that produce the magnetic field when current passes through them. These parts work together to create rotation. When DC parts is supplied, the current flows through the armature windings, and the interaction with the magnetic field produces torque that turns into shaft. Types of DC motors. There are several types of DC motor depending on how the field windings are connected. 1. Series DC motor. Is this motor the field windings are connected in series with the armature? It produces very high starting torque, making it sustainable for cranes, hoses, and elevators. 2. Shunt DC motor. In this type, the field windings is connected parallel shunt to the armature. It provides constant speed, which is useful for mechanicals like lathes and fans. 3. Compound DC motor. This combines the characteristic of both series. The shunt motor has good start torque and better speed regulation. 4. Permanent magnetic DC motor. Instead of field winding, this motor is used permanent magnet to produce the magnetic field. It is commonly used in small devices such as toys, small fan, and portable tools. Advantage of DC motor. DC motor offer several advantages: easy speed control, high start torque, simple design, reliable performance. Because of these benefits, these motors are widely used in industries and transportation systems. DC generator. DC generator is a machine that converts mechanical energy into electrical energy in the form of direct current. It works on the principle of electromagnetic induction discovered by Michael Faraday. According to this principle, when a conductor moves inside a magnetic field, an electric voltage is induced in the conductor. This induced voltage causes electric current to flow through an external circuit. Main part of a DC generator. The DC generator has almost the same part as a DC motor. 1. Field system. Produce the magnetic field. 2. Armature. The rotating part where the electrical voltage is generated. 3. Commutator. Convert alternating current produced in the armature into direct current. 4. Brushes. Transfer the generated current to the external circuit. 5. Shaft and bearings. Allow the armature to rotate smoothly. When mechanical energy from turbine, engine, or other prime mover rotates the armature, the conductors cut through the magnetic field lines, inducing an electrical voltage. The commutator then converts this into DC output. Types of DC generator. DC generators can also be classified based on how the field windings are connected. First, separately excited DC generator. The field winding is powered by an external DC source. Second, self-excited DC generator. The field winding receives current from the generator itself. These types of includes shunt generator, series generator, compound generator. Each type has different voltage characteristic and application. Application of DC generator. DC generators were widely used in the past for supplying power in industries and changing batteries. Today they are still used in some applications such as battery changing system, electroplanning, laboratory testing, DC power supplies. All Germany systems now use DC generator. DC generator are still understanding electrical machines. Difference between DC motor and DC generator. The main difference in the two machines is the ratio of energy conversion. DC motor convert electrical energy into works based on the force used to produce motion. DC generator convert mechanical energy into electrical energy works based on the conversion used to produce electricity. First, the structure of both machines is very similar. In fact, a DC motor can operate as a generator, and a generator can operate as a motor if the energy flow is reversed. In conclusion, DC motor and DC generator are essential electrical machines that play an important role in many technologies. A DC motor converts electrical energy into mechanical motion, making it useful for machines that require movement. On the other hand, a DC generator converts mechanical energy into electrical energy using electromagnetic induction. Both machines share similar components such as the armature, commutator, brushes, and field windings. Understanding their operation, types, and application help us appreciate how electrical energy can be converted into useful forms